In section 6.5, we're going to use everything that we've learned so far about radicals and use it to actually solve square root and other sorts of radical equations. So to start here, let's say we have the equation 3 plus the square root of 2x minus 3 equals 8. And I want to solve for x. So what I'm going to do here is I'm always going to try to get that radical by itself, similar to like when we worked with absolute values and stuff like that. So I'll subtract both sides by 3. And now I'm left with the square root of 2x minus 3 equals 5. Now the opposite of taking a square root is to square this. So that's what I'm going to do to both sides to get rid of that radical. I'll square both sides, and now I'm left with 2x minus 3 equals 25. Now I have a simple algebra 1 equation. I just get x by itself, and I'm done. And especially now that we're starting to work with radicals and roots, you're always going to want to be in the habit of checking your equations in case you have an extraneous solution. So here I'm going to plug 14 back into my original equation, and I will see that if I plug that into my calculator, 3 plus the square root of 2 times 14 minus 3 will in fact give me 8. So I'm good to go there. Now where things can get a little bit tricky, to solve equations of the form x to the m over n power equals k, how I'd get rid of that power is to raise each side to the n over m power, or in other words, the reciprocal. An important thing to note here is that if m or n in this fraction is even, then my answer here is going to be the absolute value of x, okay? So when that exponent cancels out, what I'm left with is like the absolute value of my base. So let's look at an example. Here I have the equation 3 times x plus 1 to the 2/3 power equals 12, and I want to solve for x. Again, first thing I'm going to do is get that radical equation by itself. And now I want to take both sides to the reciprocal power to get rid of that 2 over 3. So I'm going to take the left and the right to the 3 over 2 power. When I do that, the powers on the left are going to cancel because remember, a power to a power, you multiply it. Multiplying by a reciprocal cancels everything out. And then I'm left on the right side with 4 to the 3 over 2 power, which if you plug that into your calculator will give you 8, but I'm going to write this down as plus or minus 8. And why am I going to do that? Because I'm taking 4 to the 3 over 2 power, so I'm taking this to an even root. Now what I'm going to do, x plus 1 could be plus or minus 8. I'll separate these equations out, and I'll see that I can have answers of x equals -9 or x equals 7. And if I plugged both of these back into my original equation, I would see that they both in fact work. So now let's look at another equation. I have the square root of x plus 7 minus 5 equals x. Again, I want to get the radical by itself, so I add both sides by 5. Now I have the radical alone. I'm going to get rid of it by squaring it. This might seem a little bit weird because I have a binomial on the right side, but I'm just going to FOIL this. You'll see here this is a perfect square binomial, so you might know the shortcut to write this in expanded form anyway. I'll have x plus 7 equals x squared plus 10x plus 25. And now I have a quadratic equation, so I'm going to use tools that I know to solve for a quadratic all the way back from chapter 4. When I have a quadratic equation, to solve this, I want to move everything to one side. So I'm going to subtract the x on both sides, and I'm going to subtract that 7 as well. So now I'm left with x squared plus 9x plus 18. And I could think about doing the quadratic formula here. I also could think about, okay, do I know any factors that multiply to give me 18, add up to give me 9? And you might be thinking 6 and 3 could work here. So now I have this equation factored out to x plus 6 times x plus 3. So my two solutions could be x is -6 or -3. Finally, again, as I said before, you want to make sure that you're checking your solutions here, because in these situations, you might get extraneous solutions where like you get a proper answer for the problem, but when you plug it back in, it doesn't work. So let's do that with -6 and -3 and see if they both work out. When I plug in -6, I end up getting the square root of 1 minus 5 equals -6. Now the square root of 1 is just 1. 1 minus 5 will give me -4, which does not give me -6, so this isn't going to work. So that's an extraneous solution. Now let me try it with -3. When I plug in -3, I end up getting the square root of 4 minus 5 equals -3, or 2 minus 5 equals -3. I can look at that. I know that's going to work out. So in this problem, after double checking, I can confirm that -3 is my only solution for this equation. Finally, let's look at a problem that has two radicals in it. So this might one might look a little bit tough because I don't have just one radical, so it might seem difficult to know what to isolate. What I'm going to do here, I'm comparing these two radicals. I'm going to isolate the most challenging looking or the most complex radical, and that's going to be that 2x plus 1 because I have a binomial in there. So what I'm going to do is I'm going to add over that square root of x. And now that that more complicated radical is isolated, I'm going to square it. Now on the left, that goes away and I have 2x plus 1. And on the right side, I'm going to expand that and FOIL it. And when I do that, I'm going to get x plus the square root of x plus the square root of x plus 1. Simplified, combining those middle terms. On the right side, I have x plus 2 square root of x plus 1. Now here, I can see I still have a radical, but this is going to be a little bit easier to work with. I'm going to cancel out those 1's on both sides. I'm going to combine my x's. And now again, I still have a radical, so I'm going to do that same process again. I have a square root, so the opposite here is going to be to square both sides. I have x squared equals 4x. So here, again, I have a quadratic equation. To solve, I'm going to get everything to one side. Here, I see I have a common factor of x. I'm going to pull that out. So then my two possible answers are x equals 0 or x equals 4. And again, finally, I want to make sure I'm double checking both. I plug in 0 to my original equation. That's going to work out. I plug in 4 to my original equation. That's also going to work out. So both of these are solutions for that original problem. And I'm done.